Okay. Oh, yes, thank you. See, I forgot. I thought to remind you. Which one am I looking at? It's the next one, isn't it? Second derivative. Yeah, which one do you want to do? Yeah, so which one? This one, is it? Oh yeah, this is the whole one. So I can move along? Yeah, so the short will do that. Right. So just before we start this, just a quick question on page 88. It's 2W. Here I'm asking you for the stationary point and the nature of the stationary point. So first I have to find where the stationary point is. So I do that by calculating the derivative. But before I calculate the derivative, one small thing I'll do is I'll bring this 16 down in the front by using my rules of log. So the derivative is 16 over x minus 4x, 0. I multiply everything by x. 16 minus 4x squared plus 12 equals 0, 12x. I divide everything by minus 4, so that's minus 4 plus x squared minus 3x equals 0, or in other words, x squared minus 3x minus 4 equals 0. I can factorize this as x minus 4x plus 1 equals 0. So I get x equals 4 or minus 1. Now, we need to take these two answers and put them back in here to get the y's. But please, put them back in when it has a power 16. So firstly, the minus 1. Well, I know log of 1 is 0, so that's gone. So that's a positive. So minus 2 minus 12 is minus 4, minus 21? People with calculators, person without calculator. People with calculator, tell me the answer. Come on, hurry up, I'm getting old here. Come on. Faster, give me a number. 21.181. For which? That could be wrong. You have too much faith in me. That answer to that could be wrong. I'm checking on your calculator. Omar, do you have a calculator? You're all taking a shockingly long time to do this. 31 point... Okay, what about the other one? Is it correct? Please check. Thank you. Are you sure? Is it minus 25? Someone else got that? Look! It's minus 29. Okay. Your teacher worries when you can do this quicker without a calculator. Okay, anyways, we know our 2 points, but we need to know if they're maximum, minimums, or what they're doing. So we need to look at the second derivative now. Now, what I need to do here is change this one into 16x minus 1 so I can calculate the derivative. That would be minus 16x minus 2 minus 8x plus 12. Okay, so let's put the, let me just clean this up a bit more actually. Minus 16 over x squared minus 8x plus 12. So let me put the 4 in first. So if I put the 4 in here, I get minus 1 minus 32 is minus 33 plus 12 is minus 21, is it? Can you just put in 4 into that please and tell me what you get? Well, yes, I agree. I think it's less than 0. It's negative, yeah? Okay, it's negative, yeah? So if it's negative, then we know what type of shape is it. It's kind of like this concave shape when x is 4. Now, what about when x is minus 1? So if I put in minus 1, I'll get minus 16 plus 8, which is minus, it's a positive then. If I use minus 1 in here, I'll get a positive, which then makes it a convex shape. So, what was my first answer? What was it? 4 and 31. So that's like here, roughly. And then what was my second answer? Minus 1 and minus 21. So what shape is it here at the minus 1? What did we say it was? Convex was at the minus 1. So that's this kind of shape, isn't it? And what about here? Concave shape. So I feel like the graph is probably doing something like this. Please. Let's have a look at it nicely. What's wrong? They don't connect because you cannot have, if you go back to the top here, you can't use x as 0 in logs. So they're broken at 0.
When it's minus 1, isn't it equal to 4?
Minus 1?
Yeah.
The y is minus 21. When it's 4, it's 31, the y.
When we replace it now.
The 4 and 31, that's the point, xy. Yeah. I just wrote 31, but it's 31.18. That's the xy and the xy. Anyways, let's have a look at a nice graph. Can you read out the equation to me? What was it? Log x power 16 minus 7. Right. Because I go up to 30, I probably want to shrink this a bit. And do I go to minus 4? What's my biggest x value? Is it 4 or minus 4?
4 or minus 4.
Okay, so I'll just zoom out a bit here. Right. Ready? Just hold on to your seats. Oh yeah, it's like not the same. They're both concave. So did somebody give me the wrong number for the second one is
It's 4.
Well it's positive.
Yeah, it's positive.
So positive.
When I replace x now by minus 1, it gives me 4 because minus 16 over 1 minus.
Hold on. Right, when you put in 4, do you get positive or negative? Answer.
I
Negative, okay. And then when you put in minus 1, do you get positive or negative? Negative. So they're both negative.
Sorry, was it?
Look, it's been a very long week. So one is negative,
And the other is
the other is positive. So the negative one is concave and then convex. So it should go convex and concave. Yeah, it is. Unless... What's that? Here. Oh, you're right. Thank you, Brandon. At least somebody's listening. Yeah, what happened is your teacher's tired. That's what happened. The second derivative is this one, and then derivative of minus 4x. Yeah, minus 4. I was looking at this line. I should have been looking at this line. So it's minus 4. So I have a feeling now if we put in 4 and minus 1, they both will be negative. Can you check that? So if you put in 4, you'll get negative. And if you put in minus 1, also negative. They're both going to be negative. Negative and negative. So if both answers are negative, then they're both concave. Good. Which is what this shape is. Alright. Sorry, can you fix on your notes? So they both are negative when you put them into the second derivative here. When you put in 4, you'll get minus 3, I think. And then when you put in minus 1, you'll get minus 20. So anyway, the key thing here is they're both negative, which means they're both concave. I hope this helped, Ali. Did it help? Are you sure? A little bit? Alright. Okay, did you write that down? Yeah? Okay, so we'll go back here. Tangents and normals. Find the equation of the tangent to y equals sine x at x equals 2. So this last lesson on derivatives is just using the derivative to find equations of tangents and normal, because after all, what does the derivative represent? Slope of the tangent, yeah. So let's have a look at an example here. So write this question down, please. Okay, so just a very quick sketch here. Here is sine x, and then here is x equals 2, and what we're trying to do is get the equation of the tangent line at x equals 2. So, what is the equation of a line? Well, that's just y equals mx plus c. Yes, b if you're American. Now, first we need the point here. So the x is 2. Do we know the y? No. But we can just put it in here. So can you tell me what sine of 2 is in radians? 0.88? Close. 909, yeah? Alright. Now, any ideas on how we can get the m? How can we find the m? Yeah, dy dx. And what's the derivative of sine? Cos. And what is cos 2? What is it, minus? 416, yeah? So we now have y equals mx plus c. Okay. Now, how can we find the c? Substitute what? This point here, isn't it? So if I substitute that in, I get 0.909 equals minus 0.416 times 2 plus c. So c equals 0.909 plus 0.832. So c equals 1.741. Can you check that? True? Yeah. But if you didn't use your calculator, you could do it quicker. Yeah? Okay, that's right, yeah? So we have our answer, y equals minus 0.416x plus 1.741. Okay, so that's an example with a tangent. And so let's have a look at an example with a normal. No, I've got a better idea. I'll give you one like a tangent to try, then I'll do a normal. Then you can try one with a normal. And then I think actually it'd be good before we finish to have a look at another practical problem from the lesson earlier today. Okay? So let me give you one with a tangent to try. Can I scroll down? So this time we have, no, that's wrong, sorry. This graph. This is y equals ex. And I would like the tangent here at the point 2. So I would like the equation of the tangent here at the point 2. So give this a go, please. Try this. Okay, nearly finished? So, firstly, our point would be x2 and y, which is e squared, which is
7.389.
389. Okay. dy dx, what does that equal? Ex, e2, which is 7.389. So y equals mx plus c. We put the point in to get the c. 7.389 equals 7.389 times 2 plus c. So c equals minus 7.389. No, don't need a calculator. It's okay, thank you. So y equals mx plus c. So this is the answer. You got that? Okay, so let's do an example with a normal now. I don't think I've told you what a normal is yet. I can't remember if I have. Does anyone know what a normal is? No? Yeah, a normal is just perpendicular to the tangent. So, for example, here in red is the tangent, and can you see here in blue, that's the normal. It's just perpendicular to the tangent. Okay, can I scroll down? Yeah. Yeah. X, EX? Oh, the X doesn't come down. The derivative of EX is EX. Okay. So here's my graph this time. This here is the point -2. Now I don't want the tangent though. I want the normal here. This is what I want. Right, so when x is -2, what's the y here?
0.
Very good, 0. Now I need to get the slope. So what's dy dx? -2x. And what's the x? So it's 4. Is that the slope of the normal? No. Slope of the tangent. So what's the slope of the normal? -1/4. Because? Perpendicular. So we have y equals mx plus c. We put our point in to get the c. 0 equals a half plus c. So c equals -1/2. So y equals -1/4 x -1/2.
Why is it equal to -1/4 to perpendicular?
Correct. Yep. Okay. Here's my question for you to try. Same graph, different point. Here at the point 2, there is a tangent and there is a normal. I want the equation of the normal at the point 2, please. Same graph, different point. Finished? Finished? Let's have a look. So what is the point here? 2 and 0. So we already have dy dx calculated. Dy dx equals minus 2x, which here would equal minus 4. So what's the slope we have here? 1 over 4. So y equals 1 over 4x plus c. Now I take my point and put it in. So now I get 0 equals a half x plus c. Yeah? Oh, sorry, what am I doing? I put 1 over 4 times 2. So that's 1 over 2 plus c. So here c equals minus a half. So now I have y equals a quarter x plus minus a half. Final question here. Calculate where the normals meet. Calculate where they meet. Got the answer? No? Got it? No? So I can see from you can actually almost see the answer from the two equations. If you look at those two equations, you can almost see that the answer is x is 0 and y is minus a half. But we'll just use the method of substitution. So we have minus a quarter x minus a half equals a quarter x minus a half. So you get a half x equals 0, so then x equals 0. You put that back in and you get y equals minus a half. So these meet at the point 0 minus a half is where they meet. They sometimes do this in the exam, you know, they would say find the tangent here, find the normal here, where do they meet? You get this in the exam sometimes. Right, let's have a look at a practical problem. I would like you to try it first and then I'll do it. And the one I'd like you to do, let's see it. Oh yeah, well let me just tell you the homework from these. Questions 1 to 10. Yeah, 1 to 10. On page 92. Okay? So if we go back to page 90, I would like people to try number 6. Try number 6 for me. Successful. So what's happening in this question is you have a square piece of paper. And I say in the question you are to cut a corner away from each corner. And then what you're to do is to fold it up to make a box. but this box has no top, okay? It's an open box. So my question is, how much do you cut? I mean, if you cut too much, your box will be very skinny and very tall. And this is bad. Likewise, if you cut too little, your box will be very wide, but not very tall. This is also bad. You want something in the middle, and not too tall, not too short, not too wide, not too skinny. Okay. Now, you're right, there's no numbers in it, so we're going to have to do things like, say the rectangle is length L, and the piece we cut off, we'll call it X. We cut off X. So X and X here, X and X, and then here, X and X and X and X, and then here. These are squares, of course, X and X and X, and X, 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 and X. Okay.
So we find the area of each
That's what, yeah. We could. But before we do anything, we should put our letters in here. So how high is this box? X. Yes. And how wide is this box? No?
L minus
L minus 2x, because it's L and then we cut away an X and an X. And how deep is this box? This part. It's the same, isn't it? L minus 2x. So what is the volume here? Well, it's x multiply L minus 2x multiply L minus 2x. How many variables do I have in this equation?
3.
No, 2. Very good. What are they? X and V. L is not a variable. L is a constant. We just don't know what it is. But the page we have is a fixed size. We're not changing the size of the page. We're only changing what we cut and the volume we make. But the L is fixed. The only reason I'm writing L in is because of ignorance. I don't know what it is, but I do know it's constant. I know that the page is not changing. Okay? What I am changing is how much I can cut off and the volume I can make. So the L and the V are, the X and the V are the variables, the L is the constant. So let's multiply this. V equals X, L minus 2X squared. V equals X multiply L squared minus 4LX plus 4X squared. So V equals 4X cubed minus 4LX squared plus L squared X. I want to make the volume maximum, so what should I do next?
We find the first derivative.
First derivative here will be what? X squared
minus 8
X
plus
L squared, very good. And this should equal 0. The problem here is we don't know what the L is. So we can't factorize, we can only use our formula. So we have X equals minus B plus or minus the square root of B squared minus 4AC all over 2A. X equals 8L plus or minus the square root of 16L squared all over 24. It is 16, isn't it? 64 minus 48. X equals 8L plus or minus 4L over 24. X equals 12L over 24 or x equals 4L over 24. So this is a half L is my first answer. And then my second answer will be 4 over 24, 2 over 12, 1 over 6L. So I have two answers here of how much I should cut away. So for example, the L is just, the length. So if the length was 100 centimeters, then how much should I cut from the corner? 100, in this case 100 divided by 6. What's that? About 16 centimeters I should cut. Anyway, one of these answers makes sense and one of the answers do not make sense. Which answer does not make sense? Which answer is ridiculous? Yeah, why?
Because it's
That's it. You cut half the page off from both ends, you've got no paper left. So we reject this answer as being ridiculous. And we take this answer. Now this isn't finished because we don't know if this is a maximum or if it's a minimum. We hope it should be a maximum. So do we still have the first derivative here? Okay. So can you tell me now what the second derivative is? If you look at your notebook, what do we get? 24x minus 8? Oh. Now, if I put this in here, I will get 4L minus 8L if I put this in for x, which is minus 4L, which is negative, which makes it a maximum, which makes us happy. Well, makes me happy anyways. So, you can actually try this out. If you have a square piece of paper and you measure the side and you divide it by 6 and you cut that square away from each corner, okay, so you cut them away, you fold it up to make a box. That's the biggest box you can make. It's the biggest box, the box you can put most things inside of. Any other box will be smaller than that. Okay? And I mean, this is good because, if you were ever in engineering or a factory or, even in, not just engineering, but in other sciences too, these problems are very common. They're called, I don't know if anyone knows this word, optimization. Do some people know this word or not? Does anyone know optimization, the meaning? Yeah? Yeah, so optimization just means making something as best as possible, the cheapest way or the biggest way or whatever. So in science and engineering, optimization is a big part of it. Even if you think about things like medicine, think about all these problems you have in medicine. You want to make your machine as cheap as possible. You want to make your vaccine as cheap as possible. But you want to make your vaccine as effective as possible. 90% of problems in science and engineering are things like how can we make this better or cheaper or stronger. Okay? And calculus is a useful mathematical tool for this. Okay, so there's only a few minutes left, so why don't you try the first practical problem there. It's very short, just to make sure you can do some of them before you go home.